Okay, solving SAT official exam. Part 2, number 5. A triangle has a perimeter of 13 and one side of length 3. Okay, let's stop. The perimeter is 13 and one of its side length is 3. We all know that the sides of the triangle, when we add them, they will give me the perimeter of the triangle. So the perimeter equals the sum of the sides of the triangle, which are all equal 13. One of them is 3. So what will be the answer of the other two sides together? Of course, we're going to subtract 13 minus 3, which is 10. 10 is the sum of the other two sides. Type. Look at this information. If the length of the other two sides are equal to each other, what is the length of each of them? Of course, if they are when I have two sides and they are equal, I will divide them by 2. So my answer will be 5. 10 divided by 2, which is 5. So B is my answer will be number B. Let's go to number 7. Instead of 6, 6 will be solved later. Squaring the product of z and 5 gives the same result as squaring the sum of z and 5. Okay, squaring what? The product of z and 5. Take care, this is the trick here. The product of z and 5. How? Here I didn't square z alone or 5 alone or z alone. I squared their product. So first multiply z by 5. This is the trick here. Z times 5 is 5z. Then square z times 5. So my answer either to be B or D. 5 times Z all squared, all to power 2. Okay, either to B or D. Let's complete reading. Give the same result as squaring the sum of Z and 5. Again, I will not square Z, then I add it to the square of 5. I will square the sum of Z and 5. So which one is the right answer? Yes, Z plus 5 all to power 2. It's as easy as that. So number D will be the right answer. Let's go to number 6. Yes, we have here a table. The table is between, sorry, 1 minute. It expresses a number of hours worked by students, okay, according to their ages. Here, y-axis for the ages of the students and x-axis for the number of hours that they can work. Let's read. The grade above shows the number of hours worked last week by 12 students. So all students are 12 of various ages at after-school jobs. Which of the following is true according to this grade? Fine. Here, let's read the first one. Half 1 minute. Okay, half of the students worked more than 12 hours each. Fine, let's go to number 12. At the hours, here 12 hours. If they work more than 12 hours, so I'm gonna start from 13. Let's count the students who worked for more than 12 hours. Okay, two here, two worked for 13 hours, two worked for 14 hours, one work for 16 hours. There's some 1, 2, 3, 4, 5. And the students are 12. Is 5 half the 12? Of course, no. So we're gonna cancel this one. This one is not the right one. Let's check number B. Okay. One student worked exactly 15 hours. Let's go to 15 hours. Actually, none of the students worked 15 hours at all. So by the same way, number B is gonna be cancelled. Okay. I'm sorry, B only is cancelled. Okay. C. One 16 years old worked more than 11 hours. Again, what's meant by more than 11? Started from 12 hours. Okay, 12 hours. Do we have one 16 years old worked more than 11 hours, which like 12. Now, 12 hours, the age of the student who worked 12 hours is 17. So is it right? No, so it's supposed to be cancelled also. Let's go to number D. More 18 years old than 17 years old worked at least 13 hours, which means that the students which is 13, I'm sorry, is 18 years old are working at least 13 hours. Their number is more than the students who is 17 years old, and by the same way they are working for at least 13 hours. طب let's check first the number of students who worked at least. What's meant by at least first? At least means 13 and more, and the smallest number of hours is 13. So all the numbers of hours which are more than 13 are included. Okay, like 13, 14, 15, 16, and so on. Let's count first the numbers of students who's 17 years old. Okay, how many? One for worked for 13 hours, another one for 14, so they are two, nothing is more. Okay, two of the students of age 17 years old. Look at 18 years old, of course. 1, 2, and 3. 1 for 13, 1 for 14, 1 for 16. So, does this answer match our situation? Yes, more 18 years old than 17 years old worked at least 13 hours. So the right answer will be number, of course, D. Okay, here the right answer will be D. Fine. Number 8. If as many 7 inches pieces of wire as possible are cut from a wire that is 3 feet. Fine. Let's imagine we have a wire with length 3 feet. Okay, and we here are talking about 7 inches. So clear that we're gonna convert either from feet to inch or from inch to feet. The easier is to convert from the big to small, and it's given here that 1 foot equals 12 inch. So to change from 1 foot to 12 inch, we're gonna multiply by 12. So first of all, I will change the feet to be inch. 3 times 12, which is 36. Now it became what? Inches. Fine. So the length of the wire is 36 inch. And I want to divide it into 7 pieces of wires. Simply divide it. Cut it means division. So 36 divided by 7. Of course, 36 is not in table 7, but what's less than 36 in table 7? Yes, 35. So I can divide 35 by 7, and my answer will be my answer will equal 5. 5. What the remainder? 36 became 35. What the remainder? Remainder is 1. So the question here is, what is the total length of the wire that is left over? Okay, the left or the remainder length of wire is gonna be 1 inch. So your answer will be A. Thank you, and I hope that you understood this part. If you liked the idea, please share, subscribe, and like.